Hey guys, Mr. Nichols here. Hoping you guys had a fantastic weekend. So, today we're going to be talking about different kinds of evidence. So, we're going to be actually talking about multiple different categories throughout the entire semester, but we're going to start off with two very broad categories of different types of evidence. Now, they're both going to have slightly different practical uses for different investigations. And we're going to talk about some of those applications here today. And we'll also get some practice identifying what different types of each of those different types of evidence are. So I would strongly recommend documenting these notes somewhere in your notebook. I have also posted these slides. So if you missed something, you can always pause the video and go back, or you're welcome to look at the slides instead. Okay, so as the name suggests, individual evidence is going to be evidence that we can narrow down to one specific person, to one specific individual. Now, that in order to narrow our field of suspects down to one person, we always need to compare that individual evidence to something. So meaning that evidence that was collected at the crime scene needs to be compared with an object that was maybe collected from the residence of a suspect, or was collected from the actual suspect once they were taken into custody. So although we can never say with 100% certainty that that specific piece of evidence without any doubt came from one specific person, statistically we can't do that. But we can say within a reasonable range of likelihood that something came from someone. So for example, if we think about fingerprints, the likelihood of two people having the same fingerprint is about 1 in 1 times 10 to the 60th. So if we think about the population of the Earth, it's very unlikely if we only have 10 to the 9th people on the planet, if it's the likelihood is 10 to the 60th that two people have the same fingerprint, it's just not probable. It's not statistically significant. It's not likely. We can't say that it's 100% uncertain, but we can say with strong confidence that two people are not going to have the same fingerprint. So some examples of individual evidence or unique characteristics that would be down for one specific person. And we'll talk about each of these different kind of categories of evidence here more in a sec. For class evidence, I should say. So if you think about shoes, so let's say that we found a shoe print in the dirt outside of a crime scene or in a crime scene. The specific wear pattern of that shoe is unique to one specific person. Believe it or not, if you look at the bottom of your shoes, if you and your friend have the exact same pair of shoes, chances are the wear pattern that's on them is going to be slightly different because of the way that your body weight settles on your feet. Some of us have slight variations in how that happens. Also, is there an imperfection? Is there a piece of bubble gum that was in that shoe print? Is there a piece of bubble gum in that exact same spot on that shoe? So that would be unique for that specific person. So a paint match. So if we actually look at the physical chemical properties of that particular type of paint, same thing with fibers, those are going to be specific to that person, to that specific source. Again, we already mentioned fingerprints. Tool marks are basically small scratches that happen from normal wear and tear on a particular object. Oftentimes, those are going to be things like screwdrivers, hammers, or knives. Just from using it, there's going to be these small, oftentimes microscopic little scratches and wear patterns that break into them. So then from guns as well. So if you think about bullets, as they're traveling through the barrel of a gun, if it's a handgun or if it's a long gun, a rifle with a rifled barrel, as the bullet is traveling through that barrel, it's going to get small little scratches that go in the side of it. So every single barrel is microscopically unique, meaning that although if you were to look down that barrel and you saw that it looked pretty similar, if you took a microscope, you would see small minor imperfections on the inside. And those imperfections are unique to that specific gun, to not that specific brand. So that narrows our field down to one specific one specific gun instead of like a brand of gun. And then finally, we have DNA. So DNA is some of the strongest individual evidence because it's very unlikely, many times more unlikely than fingerprints, for two people to have the exact same DNA sequence, unless they are identical twins, of course. Okay. So we have individual evidence, and then we also have class evidence. So class evidence is going to be narrowed down to a group of people or things. So we can never get down to one specific person, but we can still narrow our suspect pool. So a good example of this is if we found a droplet of blood at the crime scene and we suspect it might be from the suspect. If we know that it's A-type blood, now we can narrow our suspect pool down to just people who have A-type blood, right? So we're not getting it down to one person. We're getting it down to a group. Okay, so looking at some similar kind of objects and pieces of evidence. So if we found a pair of, well, not if we found a pair of shoes. Let's say that we found a shoe print outside of the residence, but we can't really make out any specific wear patterns or anything like that. But we know that it has a specific style. It's a specific style of shoe. So let's say that it was a Nike Air Jordan and we know it was a size 9. So we don't know which Nike Air Jordan it is because there's a lot of people who most likely have that particular type of shoe. But we have still narrowed our pool down to people who just have that particular type of shoe. Not a specific one shoe, but a group of people who have that shoe. Same thing for like paint. If we look at the chemical composition of a paint that was maybe left by at a hit and run, we might be able to figure out what make, model, and year that car was from. So now we've narrowed it down to how many people own that particular type of car, but it's still going to be a group of people. It's not one specific person. Okay. So same thing with fibers here, kind of as paint. So if we look at microscopically, look at what type of fiber we have. So maybe it was from like a sweater. If we have a red fiber that seems like it was from a sweater, we can't narrow it down to one specific source of that sweater because many people could have that exact same sweater. So for fingerprints, if we can't see any identifying marks, we can maybe figure out what shape of fingerprint that was. Tool marks, so we could look at maybe what type of knife caused a particular wound, or what type of hammer, what type of screwdriver. So we might not be able to figure out those little scratch patterns from that particular item, but we can figure out what general type or brand of object that is. Same thing for guns too. As we mentioned before, if we're going to have a piece of individual evidence, we have to have something to compare it to. So, for example, if we find a bullet that was left at a crime scene and we are not able to find the weapon, we are not able to find that original gun, then we cannot use that as individual evidence because we need to collect that gun and do a test fire of that specific gun. Not that brand of gun, that specific gun, so that we can see that microscopically unique scratch pattern that would be on that bullet. But we can figure out what type of bullet it is. We can figure out what type of gun it came from, but we can't figure out the one specific gun that it came from. Okay. All right, so let's look at a couple examples here. So let's say that we have these little green fibers that were found at a crime scene, and then we got this sweater from a suspect that from the residence of a suspect there. So now in the bottom here, let's say that this top part of this bottle was found in the car of a suspect, and these shards of glass down here were found at the residence, So for the second one, let's say that the top of this bottle was found at the residence of a suspect. And this section that's on the bottom here, these broken shards of glass, were found at the crime scene. So go ahead and take a moment, think to yourself about whether or not the green sweater And those little fibers would be an example of class versus individual evidence. And then think about the glass example as well. Would this be class or individual evidence? All right, so let's think about this here. So we've got these mysterious little green fibers, and we think that they might have came from this sweater. If we think about it, is it possible that more than one person has gone out and bought this sweater? Yeah, absolutely. So this would be an example of class evidence. There's no way for us to figure out that these fibers came specifically from this one sweater. So this would be an example of class evidence. So this bottom one here, if we think about this here, can we fit these smaller pieces of shards of glass on the bottom in the broken sections of the larger piece of glass? Yeah, we can physically fit them together like two puzzle pieces. So this is going to be an example of individual evidence because we can hold them up together and we can see that they physically match with each other. Especially for something that's as variable as broken glass, having two pieces match up is pretty compelling evidence. So individual evidence definitely narrows us down to one specific person. But unfortunately, individual evidence is often very difficult to come by. So what we often need to do is we often need to use multiple examples of class evidence to connect one person to that particular crime scene. So what we're going to do is we're going to use statistics and probability to try and figure out the likelihood that someone was at the crime scene, that someone was connected to that crime scene. So essentially what we're going to do is we're going to multiply the frequency or the likelihood of independently occurring characteristics. And we'll explain what that means here in just a moment. So let's look at an example. So probability is just the frequency or the likelihood of something happening, an event happening. So it's going to fall somewhere between 0% and 100%. So let's look at the example of if you were trying to roll a die. So if you rolled a die and you wanted to get a 6, you've got a 1 in 6 chance, right? So if we, take 1 divided by 6, that gives us 0.167. So if we convert that to a percentage, that gives us 16.7%. So you have a likelihood, if you're rolling a die, if it's an evenly weighted die, of 16.6%. So now let's say that you wanted to roll 2 die in a row. So now we can do the same thing. So we can take our 2 decimal values. We want to use our decimal values, not multiply the percentages, not multiply fractions. That will just get more complicated. So you're just going to multiply those 2 decimal values together. So you'll do 0.167 times 0.167, and we get 0.028 or 2.8% if you multiply it times 100. So again, when we're talking about 2 independent events, this first roll does not impact the second roll. Your likelihood of getting a 6 is going to be the exact same both times. So now let's say that we're trying to roll 3 6s in a row. So now you're going to do the same thing. So multiply 0.167 times 0.167 times 0.167. And now that would give us 0.0047 or 0.47%. Now, if you notice, the more events that we're adding, the more objects that we're adding, the smaller that percentage is getting. And that's the key part. We're trying to narrow our field of suspects. We're trying to make it as small as possible. So we want our percentage to be as small as possible. So let's look at an example. So this is going to relate a little bit more to how we can use class evidence and determining the value of it. So let's say that there was a robbery. Okay, so someone broke into someone's house and stole a bunch of goods. So let's say that neighbors, so witnesses, saw someone fleeing the scene in a red Ford Mustang. Let's also assume that inside of the house there were some fine powders that were found from a manufacturing process in a manufacturing plant. So that leads us to think that the culprit might work at a manufacturing plant. And then let's say that outside of the house, there was a boot print that was a size 9 men's Ariat boot. So what we can do is we can figure out in the Denver metro area how many people have each of those different objects, right? So if we think about it, we could say, and we can look at DMV records, we can figure out how many people have red Ford Mustangs. So let's say that 2% of the Denver metro area owns red Ford Mustangs. So we can look at, jobs records, labor statistics, and we can figure out how many people work at manufacturing plants. So let's say that about 14% of the Denver metro area work at manufacturing plants. And then this one is a little bit tricky, and we'll talk about why here in a couple minutes. But let's say, for example, that 0.05% of our Denver metro area population owns these Ariat boots. So how are we going to go about tackling this problem? Well, what we're trying to do is we're trying to figure out the likelihood of one person, or at least a small group of people, having all 3 of these characteristics based on how many people in the Denver metro area do have each of those characteristics. So first thing we got to do is we got to pick out what are the percentages we're going to be using. What are the likelihoods? Okay. So then the percentages, we need to convert those into decimals, right? So we're going to take the percentages and divide them by 100. Then we need to combine all of those events. So that's the product rule. So we're just going to multiply all those decimal values together. That's going to give us an overall working number, a decimal number, because we always want to convert to decimals when we're dealing with probabilities and likelihood. And then finally, we take our answer from that and then multiply it times 100 to convert it back to a percentage. So let's take a moment and let's go ahead and look at a Jamboard, and let's look at this specific example here. So, and I apologize, my screen's going to probably bounce around here a little bit. So if we remember correctly, we had 2% of our population that drove red Ford Mustangs. Okay, 14% of our population work at manufacturing plants, and then 0.05%, okay, own those men's Ariat size 9 boots. Okay, so first things first, we have to divide each of these by 100. Okay, and that's going to give us a decimal value. So that's going to give us here a decimal value of 0.02. Here a decimal value of 0.14. And a decimal value here of 0.0005. Okay, so now we've got all of our decimal values here. So now we need to multiply all of these values together. Okay, so if we multiply all of those values together, what we get is bear with me here, 0.00014. Okay, which I would recommend following along with your calculators with this one, because there will be a couple of these types of questions on our practice for today. Now, this right now is in its decimal form, so we do need to multiply this times 100 in order to get it back to a percentage. Ooh, that's a gross 0. Here we go. So that's going to move our decimal place over 2. Okay, so that gives us 0.00014%. So this means that out of the entirety of the Denver metro area, the likelihood of someone having all 3 of these characteristics is 0.00014%. Now, we're actually not done with that yet there, although that can be a valuable piece of information. What we need to do now is we need to figure out how many people in the Denver metro area is that the case for. So if 0.00014% of people have a red Ford Mustang, work in a manufacturing plant, and own a pair of size 9 area boots, how many people is that? So if we have approximately 2,800,000 people who live in the Denver metro area, all we're going to do is just multiply that value, so 2,800,000 people, times our decimal value. So we do need to convert our 0.00014% back into a decimal by dividing it by 100, because that's always going to be our working number in decimal form. So if we multiply those two values together, that gives us about 3.92 people. So we can round that up to about 4 people. So that is a very manageable number. We could go and visit 4 people and ask them some questions and see if maybe they were connected further to our crime scene there. So do you see how we've been able to now take these pieces of evidence that were once broad and would have been very inefficient at narrowing our suspect pool down, and when we combine all of them together, our suspect pool gets much, much smaller. Okay. Now, as I kind of mentioned with the boots example here, unfortunately, it's very difficult for us to get actual numbers for class evidence because of how mass-produced most things are. Excuse me. So it would be very difficult to figure out how many people in the metro area have a pair of those Ariat size 9 boots. It would be very difficult, and we would have a very low confidence in that number. But if we combine that with other pieces of evidence, that allows us to increase the likelihood of their connection to that particular crime scene. So class evidence definitely has value, and the more pieces of class evidence that we can combine together, the more powerful it can be. Okay. So as we mentioned, it's very difficult to get items from crime scenes that are going to be individual in nature. So class evidence is going to be very helpful when we can take multiple different pieces of class evidence and combine them together. So at the end of the day, as forensic scientists, we can only come up with these values to calculate the likelihood that someone was present at a particular crime scene. It's oftentimes going to be up to the judge or the jury to figure out really what the value of that evidence is. How strong of an influence is that evidence going to have on the decision of a particular case there? So this was our brief little introduction into individual versus class evidence. So today you're going to be breaking out and you're going to be taking a look at our practice worksheet for identifying class versus individual evidence, and then also look into a little bit of more practice with these calculations here. So if you have any questions, please don't hesitate to reach out. I'll be available on Remind. Just keep in mind that I will have classes if it's a hybrid day and you're remote. So I might not be able to respond right away, but I will eventually respond to you as quickly as I can. Before we break out, the other thing I do want to mention is that my surgery for my torn ACL is going to be on Friday of this week. So I will unfortunately be out for about 2 weeks. So I will have a sub, and he will be able to help us run our major activities. But realistically, most of the stuff, the materials, is all going to be posted the same way, especially while you are remote. The only thing that's going to be different is when you're in hybrid. Okay. So also on Friday, I will most likely be kind of giving you guys Mrs. Sheehy's contact information as kind of a point person while I'm under for surgery. Obviously, I'm going to be kind of out of commission that day, but I want to give you guys someone who you can go to who has at least a basic understanding of what we're doing. If there's any other major questions that you have that day, feel free to reach out. You can still send me emails and message me on Remind. But just keep in mind that it might take me a little bit longer to get back to you. So I appreciate your guys' patience with that. Hopefully I can get this surgery done and, be back to 100% here as soon as possible so we can miss as few beats as possible. So if you guys have any questions, please don't hesitate to reach out, and hope you guys have a great week, and we'll talk to you guys soon. Take care, everybody.